Hi students, in this video we are going to discuss some important points. At first, numerical number 1. Numerical number 1. We are going to discuss about some numericals as well as the concepts. Numerical number 1. The sun angular diameter, the sun's angular diameter is measured to be 1920 seconds. Full stop. The distance capital D, the distance D of the sun from the earth is 1.496 into 10 to the power of 11 meters. What is the full stop? What is the diameter of the sun? What is the diameter? What is the diameter of the sun? Question mark. Once again, my dear students, I would like to repeat the question. The sun's angular diameter is measured to be 1920 seconds. Full stop. The distance D of the sun from the earth is 1.496 into 10 to the power of 11 meters. What is the diameter of the sun? This is the question. Now go for the solution. Now consider this is the sun. Now it is the consider like this. This is alpha. This is capital D. This is also capital D. This is small d. Now here sun's angular diameter alpha is equal 1920 seconds. Now that means alpha is equal 1920 into 1 second. That is equal alpha is equal 1920 into 1 second is equal, we know that 4.85 into 10 to the power of minus 6. Therefore, alpha is equal 931 into 931 into 10 to the power of minus 3 radians. That means the alpha we find in the form of radians, because always alpha always should be radians, but it never be on seconds, so we convert it into radians. Now sun's diameter, sun's diameter sun's diameter d is equal alpha into d formula. Now that is equal, therefore d is equal alpha. What is alpha? 931 into 10 to the power of 931 into 10 to the power of minus 3 into, it is into, remember, don't go for confusion, into 10 to the power of minus 3 into, what is the diameter? This one, 1.496 into 10 to the power of 11. Now therefore diameter d is equal 1.39 into 10 to the power of 9 meters. So this is the diameter of the sun. This is the diameter of the sun. This is the sun. Remember, this is the sun. This is the diameter of the sun. So we have to, therefore the diameter is equal to 1.39 into 10 to the power of 9 meters. This is the diameter of the sun. This is the diameter of the sun. This is the whole sun. Like that we have to solve the numericals. Now we are going to discuss some concepts. Estimation of very small distances, very small distances estimation of very small distances. Here this is the concept. Here first we are going to discuss size of molecule. Size of molecule. Size of molecule. Now what is our concept? Estimation of very small distances. Example, size of molecule. Now go for the discussion. Point number 1. To measure a very small size like that of molecule in the bracket 10 to the power of minus 8 meters to 10 to the power of minus 10 meters. Now electron microscope, electron microscope with a resolution of 0.6 angstroms. being being used. Once again I am repeating this point, my dear students. To measure a very small size like that of molecule 10 to the power of minus 8 meter to 10 to the power of minus 10 meter electron microscope with a resolution of 0.6 angstrom being used. Now point number 2, it can almost resolve resolve it can almost resolve atoms and molecules in a material Once again I am repeating this point. It can almost resolve atoms and molecules in a material. Now point number 3, recently tunneling microscopic microscopy has been developed which is better than electron microscope. From now point number 4, from it we can estimate the size of molecule. Once again, I am repeating the point. It can be almost resolve atoms and molecules in a material. Point number 3. Recently, our scientists they discovered they discovered tunneling microscope has been or they are developed tunneling microscope has been developed which is better than the electronic microscope. That means the tunneling microscope is resolved more better than the electron microscope. Now from this tunneling microscope we can estimate the size of the molecule. This is about estimation of very small distances size of molecule. Now we are going to discuss about range of length. Range of length. Now go for the discussion. So, the size of orbits in the universe, I would like to explain point by point. Point number 1, the size of the size of the size of the objects, the size of the objects in the universe, in the universe, in the universe, vary over a vary over a vary over a very wide range, very wide range, wide range, wide range, full stop. Now point number 2, these may vary from, once again I am repeating the point number 1, my dear students. The size of the objects in the universe vary over a very wide range. Now point number 2, these may vary, these may vary, these may vary from the size of the order, size of order, size of order of 10 to the power of minus 14 meters of the tiny. Tiny means small. Tiny means small. Tiny nucleus. Tiny nucleus of an atom, to the size of the order of size of the order of 10 to the power of 26 meters of the astronomical objects. Astronomical objects of universe, of universe. Now once again I am repeating the point, my dear students. These may vary from the size of order of 10 to the power of minus 14 meters of the tiny nucleus of an atom to the size of the order of 10 to the power of plus 26 meters of the astronomical objects of universe. Now some point number 3, some important some important length. Some important length in daily life. In daily life. We in daily life is what are that? Point number A. My dear students, this third point we have to remember permanently, even though whether they are given in exam or not. Point number A. 1 Fermi. 1 Fermi is equal to 10 to the power of minus 15 meters. Point number B. 1 angstrom. 1 angstrom is equal to 1 angstrom denoted by 1A, that is equal 10 to the power of minus 10 meters, that is equal 10 to the power of minus 8 centimeters. This is very very important. We have to remember. Now point number C. 1 astronomical unit. 1 astronomical unit is equal 1 AU. So the meaning is that is average distance of average distance average distance of the sun from earth is called 1 astronomical unit. Now that is 1.496 into 10 to the power of 11 meters. Once again, point number C. I am repeating point number C. 1 astronomical unit is called 1 AU. 1 AU means the average distance of the sun from earth is called 1 astronomical unit, that is 1.496 into 10 to the power of 11 meters. Now point number D. 1 light year. 1 light year, that is equal, we can write it as 1 Ly, that is 9.46 into 10 to the power of 15 meters. Once again, I am explaining this point. 1 light year is equal 1 Ly, that is equal 9.46 into 10 to the power of plus 15 meters. Actually, what is light year means that is distance that light travel with a velocity of 3 into 10 to the power of 8 meter per second in 1 year is called light year. So how much distance it will be travel? 9.46 into 10 to the power of 15 meters. Distance traveled by a light per 1 year is called light year. However, that point I can write here. That is distance that light travel with velocity of velocity of 3 into 10 to the power of 8 meter per second, meter per second in 1 year. In 1 year, that is 9.46 into 10 to the power of 15 meters is called 1 light year. What is that one? 1 Ly. 1 Ly is equal, this is 1. 1 Ly is equal 9.46 into 10 to the power of 15 meters. Now, point number E. Point number E. 1 parasecond, 1 parasecond is equal to 3.08 into 10 to the power of 16 meters. Now, here, what is 1 parasecond? 1 parasecond is the distance at which average radius of the Earth orbit subtended an angle of 1 arc second is called parasecond. Now I can write that point here. Please observe carefully. That is parasecond is parasecond is the distance at which average radius of Earth orbit subtend subtends an angle of 1 arc second. Once again I am repeating, what is 1 parasecond? 1 parasecond is the distance at which average radius of Earth orbit subtended an angle of 1 arc second is called 1 parasecond. Now, point number F. Size of proton. That is equal 10 to the power of minus 15 meters. Now, point number G. Once again, size of proton 10 to the power of minus 15 meters. Next, size of atomic nucleus is equal 10 to the power of minus 14 meter. Once again, size of atomic nucleus 10 to the power minus 14 meters. Next, size of hydrogen atom. Size of hydrogen atom, that is called 10 to the power of minus 10 meters. Once again I am explaining this point. Size of hydrogen atom 10 to the power of minus 10 meters. Next, I. Point number I. Point number I. Wavelength of light. Wavelength of light 10 to the power of minus 7 meters. Point number J. Radius of earth. Radius of earth. That is called 10 to the power of 7 meters. My dear students, these 2 points are important. Please go through it. These 2 points are important. Please mind the gap. Point number K. Distance of moon. Distance of moon from the earth. Distance of the moon from earth, that is called 10 to the power of 8 meters. Once again I am explaining this point, my dear students. Distance of moon from the earth is called 10 to the power of 8 meters. Now last point, distance of the sun from the earth. Sun from the earth, that is called 10 to the power of 11 meters. Now my dear students, in this concept we discuss some important points, that is range of length. So what is the range of between sun and moon and moon and earth and sun and earth and size of atom, size of the nucleus, all these are the points we covered here. I hope you understood this video. However, thank you very much for watching this video. Thank you. My dear students, whatever I am giving these points are very important, so never ignore. Please copy in your notes. This okay. Thank you very much for your cooperation. Thank you.